Number 5. It looks like we got 2 parts. So they're giving us a formula, n factorial divided by n minus r factorial, and then we have an n factorial divided by r factorial over n minus r. These are 2 formulas for permutations and combinations. I don't know, I haven't been to the text in a little while. They may show those. Let me see if it pulls it up for a second. But this is how we come up or use those formulas with counting techniques. Sometimes when we do counting techniques, we want to count objects repeated, and sometimes we don't. That's the difference in those 2 formulas. So let me just see if they point them out here in this section, so you can kind of see where those 2 are. I would imagine so. Okay, yeah. Factorial formula, definition of 0 factorial. That's that fact I mentioned earlier. And let's see, maybe. Okay. Getting closer. It doesn't look like it shows it all together. So they may not show it, but we'll get there a little bit later. But if we were, let's say, drawing names, and we had like, let's use this example. There's 12 students. We're going to draw 4 names out. We would use permutations if there were different arrangements. So let's say that 4 names were going to be drawn out. One was going to get a $50, one was going to get 40, one was going to get 30, one was going to get 20. So in this case, order would be important because the first person would get more than the last. And using this one, it kind of divides out that repeat with that extra R down there. This one doesn't. And that way all names will be the same. But we'll go a little bit in more detail later. For now, we're just going to do this first formula, n factorial over n minus r factorial. We're given that n is 12 and r is 4. So what we get is 12 factorial and then 12 minus 4 factorial. So we get 12 minus 4 is 8. Okay, so I'm going to do 12 times 11 times 10 times 9 times 8. I'm going to stop at 8 and write factorial instead of going all the way to the end. 12 minus 4 is 8 with that factorial. And so the 8 factorials will divide out, and we're left with 12, 11, 10, 9. So we're going to multiply 12 times 11 times 10 times 9. We get 11,880. I don't want the textbook, I want the word page. So 11,000, we get 880. And then part B, we're going to do a similar formula, except we had an additional R down here. Okay, so I'm just going to pick up from that point. Alright, so we have 12 factorial, 4 factorial, and then we had 12 minus 4 factorial. Alright, so this is going to be 12 times 11 times 10 times 9 times 8 factorial. On the bottom we have a 4 factorial. So I'm going to do 4 times 3 times 2 times 1. And 12 minus 4 is 8 factorial, so I'm going to stop at the bigger of the two numbers. So those two will divide out, and we're left with 4 times 3 times 2 times 1. Okay, 4 times 3 is 12. That will get rid of this 12. Alright, 2 times 1 is 2. And 2 is, we can divide the 10 by 2, and that will leave us with 5. So we're left with 11 times 5 times 9. Much smaller and nicer to work with. You reduce as much as you can with these and multiply the least amount of digits as possible. So we have 11 times 9 times 5. And gives us 495. So 495